Hello everyone, my name is Apoorv Bapat. Thanks for showing interest in ELEATION's ANSYS Basic to Professional Training Program. In session 1, that is Theory of CAE, we are going to learn what is design validation, how many ways are there to validate any design, what is analytical method, numerical method, experimental method, how many numerical methods are there, what is finite element method, boundary element method, finite volume method, finite difference method, what is computer aided engineering, difference between CAD and CAE. So we'll start with design validation. Design validation means whether the component which we are going to manufacture will sustain for various loading conditions or not. In other words, we can say the design validation is a process to find out results like stress, displacement, strain, fatigue life, eigenvalues, heat flux, which may or may not come on the model, which leads to failure. So let's assume if I apply load on this component, then to find out the values of stresses and deformation on this component is called as design validation, that because of this load, how much the stresses is going to come and from where the exactly the failure will come is called as design validation. So there are different ways to find out the values of say stresses or deformation. One is analytical, the other one is numerical, and the third one is experimental method. So let's take a basic example of a plate which is subjected to simply supported loading. You can find out the values of stresses and deformation using the formulas available for the values of stresses and deformation. You can use numerical methods to find out the values of stresses and deformation with the help of software, or else in experimental method you can actually manufacture that plate, perform a physical testing and find out from where exactly the crack will initiate, what will be the maximum stress values and what will be the maximum deformation values. Now let's understand the advantages and disadvantages of different methods. So the advantages of analytical method is it gives 100% accurate results on simpler components. The disadvantages of analytical method is you can only find the results if you know the formula. It is very time consuming. Accuracy can't be believed blindly. The calculations are only made on single points. Now let's discuss advantages of numerical method. We can solve real life complicated problems. Results can be achieved faster. Results can be achieved on entire geometry, and it is applicable even if the physical prototype is not available. The disadvantage of numerical method is it gives approximate results. You cannot get 100% correct results using numerical method. Now let's discuss advantages of experimental method. The advantages of experimental method is the physical and manufacturing errors can be considered during the results. It gives actual measurement. The disadvantage of experimental methods are it is time consuming and needs expensive setup. It is applicable only if the physical prototype is available. You have to perform testing on minimum 3 to 5 prototypes to get the final results. Now let's see what are the different numerical methods available. So there are total 4 numerical methods available: finite element method, boundary element method, finite volume method, finite difference method. Let's see them one by one. So finite element method is a numerical technique for finding approximate solutions to boundary value problems for partial differential equation. It is also referred to as finite element analysis. The inputs which you can use for finite element methods are loads like forces, pressure, velocity, etc., temperatures, constraints. The inputs and outputs in finite volume method can vary with respect to time. The outputs you can get from finite element methods are forces, displacement, stresses and strain. So we are going to discuss finite element method in detail in session 2. So basically finite element methods tell you from where exactly the component is going to fail, what will be the exact location of maximum stress, exact location of maximum deformation. It gives you the answer on exact point location. Then let's see what is boundary element method. Boundary element method is most often used as engineering design aid similar to more common finite element method, but the boundary element method has distinction and advantages that only the surface of the domain needs to be meshed. Inputs which you can give to perform boundary element methods are loads, vibrational parameters, supports and constraints. Output which you can get from boundary element methods are vibrational effect, stresses, deformation. The inputs and outputs in boundary element method as well as can be vary with respect to time. So in boundary element method we find out the results of what is happening because of vibration, say for example noise and vibration. So what effects are producing because of noise and vibration, how much the noise and vibration are damping, how much it is not damping. So all these parameters on the boundary of the component is calculated using boundary element method. Let's see what is finite volume method. Most computational fluid dynamics software is based on finite volume method. The unit volume is considered in finite volume method similar to the finite element analysis. Variable properties at the nodes include pressure, velocity, area, mass, etc. It is based on Navier-Stokes equation, that is mass, momentum and energy conservation equilibrium equation. The inputs which you can give in finite volume method is velocity, pressure, mass flow rate, temperature, etc. The outputs which you can get from finite volume method is velocity, pressure, temperature, liquid mass, volume fraction, lift and drag coefficient. So basically finite volume method is used to find out the behavior of volumes on another volume. Say for example, if you want to find out the lift and drag coefficient of any component, then you consider that as a volume, and then you consider air as a volume, and then you find out how much air is required to produce the lift or how much air is required to produce the drag on that component. Or you can consider Venturi. The Venturi concept says that if there is a pressure drop, then the velocity will increase. So you consider the pressure area of the Venturi and the outer diameter for the velocity increase. So these types of analysis can be performed using finite volume method. Let's see finite difference method. Finite element and finite difference method share many common things. In general, the finite difference method is described as a way to solve differential equation. It is used in combination with boundary element method or finite volume to solve thermal or CFD coupled problem. Say for example, we need to find out how much stress is generated on airplane wing due to fluid, that is air. In finite volume method we cannot find stresses, but we can find loads, that is pressure exerted by air. After getting loads from finite volume method, we use finite element to get the stress results. This coupling of multiple method is known as finite difference method. So let's say air is flowing over a wing, then we can calculate from finite volume method that what amount of pressure is being exerted by that air, and after finding the pressure from finite volume method, we can use that pressure values in finite element method and find out the exact location and values of stresses due to that pressure situation. So coupling of these two methods and getting the values of pressure is called as finite difference method. Now let's see what is CAE. CAE stands for Computer Aided Engineering. Is the broad usage of computer software to aid in engineering analysis tasks. It includes finite element analysis, computational fluid dynamics, multibody dynamics, optimization, etc. CAE retrieves description and geometry from CAD database. It is used in almost every industry such as aerospace, automobile, manufacturing. CAE depends on CAD. So now let's understand the difference between CAD and CAE. CAD is about creation or generation of 3D model, whereas CAE is about testing its characteristics using engineering method. Let's take a basic example of bridge. So this is the actual bridge, the practical physical component. So representation of physical component in a virtual domain is called CAD model. We import that CAD model in CAE software. We mesh that CAD model. We apply loading conditions on the mesh model. Then we solve that model and then we get the results of stresses deformation. So the first image represents CAD and the other three images represent CA. So that is the basic difference between CAD and CA. CAD tell us the virtual representation of actual model, whereas in CAE you can find out the virtual behavior of those components on different loading conditions. So thank you very much for attending session 1. In session 2, we are going to cover theory of FEM and FEA. We are going to see what is FEM and FEA, why do we carry out meshing, advantages of FEA or FEM, what is degree of freedom, element shapes, etc. If you have any queries or doubts, feel free to contact us via query@eleation.com or you can visit www.eleation.com.